Alright, this is another example of finding the angles using dot product. So this time I want to find the angle between the diagonals of a cube. And I have it drawn out here. The green is just the axes. The black represents the two diagonals I want to find. One goes from here to here and the other one goes from the front bottom corner to the back top corner. And so to find the angle between them, I'm going to use the dot product, just the component form. A dot B is equal to AB cosine theta. And then, so I need to define these two vectors that go from the origin to these points here. So A, this vector, let's make this one A, and this one over here B. So A is in the X, it's 1x, negative 1y, and 1z. 1x, negative 1y, and 1z. And the B is similar, but it's negative 1x, 1y, negative 1 and 1z. 1y and 1z is equal to, and the magnitude of AB is just using the distance formula on these, so it's 1 squared plus negative 1 squared plus 1 squared, and then the square root of that. So that's the square root of 3. So each one has a magnitude of square root of 3. Square root of 3. And cosine of the angle between them that we're trying to find. So to do the dot product over here, this is going to be really simple. It's just since it's all 1, so it's just 1 times negative 1, or negative 1 plus negative 1 times 1, so minus 1, plus 1 times 1, so plus 1. That's the dot product is equal to 3 cosine theta. Cosine theta. Over here we have negative 1. If we divide by 3, we get negative 1/3. Negative 1/3 is equal to the cosine of theta. Is equal to cosine theta. So if we just take the inverse cosine or the arc cosine, we find that theta is equal to, it's 1.91 radians, and I used a calculator for this just a minute ago. 1.91 radians, or I like to write things in degrees if they're not one of the simple fractions, and it turns out to be 109.5 degrees. 9.5 degrees. So that's another example using the dot product. Thank you, and let me know what you want to see next.